smoker, drinker, non-drinker, like that. So this so and so forth. And similarly, it can be used to compare the fractions, ratios, like percentage, right? So these are the things, or these are called continuous variables. They can be compared using this statistical test. The presence of one set of data set does not affect the others, right? All the data sets which are there in chi-square test are independent, and the data set, already I mentioned, the data set is, since it is independent, they are mutually exclusive, means they have particular set of values which remains unaffected, right? And then data set which is there, it is not behaving in a predictable way. Like in normal distribution, the curve is slowly going up and then coming down. It's not like that. So the data set, you cannot predict out of this data set which is being provided to you. The chi-square data set which is obtained, it is usually obtained by a random sampling method. So there is no biasness in the data set. They are actual representatives of the data. Now on to the calculation. Chi-square test calculation is given as chi-square is summation of observed minus expected whole square divided by the expected value. Let us see a biological example in this regard. Uh, Generally, when we are calculating the chi-square test, we know one part of the data, that is the observed value, right? So observed value is usually given as a thumb rule, and then we have to calculate the expected value. Now, on to a famous example by work of fathers of genetics, Gregor Johann Mendel. So he worked on pea plant, and based on his observation, he noted down every day. He noted down the observations in the pea plant growth and their traits carefully in his diary. So, based on that, he could produce laws of genetics. Now, the laws of genetics, I've stated two here. Mendel's law of dominance. Now, Mendel's law of dominance means one gene expression suppresses the expression of others. Now, here in the figure itself, on the left side, you can see capital T is the dominant gene, and which denotes the tallness, and small t denotes the smallness or the dwarfness of the plant. So when he crossed the tall plant with a small dwarf plant, then he noticed in the first filial generation, most of the plants were taller. In fact, 75% of plants were taller, and only one individual had retained the dwarfness characteristic. Now, this was about one trait. Now, when he considered two traits, like in law of ascertain, he took two traits, that is the shape of the pea seeds and their color. So he took a round as a dominant character and yellow as a dominant character, and he crossed with a recessive, that is the green and wrinkled, that was denoted by small r and small y. So he could obtain the gametes which were there in the first filial generation, R, Y, capital Y and small y. So when he crossed these both of them, he found that the cross were having this. If you take the genotypes, that these four genotypes are they can be produced: capital R, capital Y, capital R, small y, small r, capital Y, and small r, y. If you cross them, there are four different possibilities or four different phenotypes which are produced. So the round yellow, actually there are total 16 numbers. Out of that 16, their round yellow is 9. Similarly, round green is 3. Wrinkled yellow is 3. So, and last is the wrinkled green. So these are the genotypes which are there, and these are the phenotypic character which are there. So phenotype, if you consider that they are divided in ratio of 9:3:3:1. So based on this, we also calculated, we obtained pea plants and calculated their seeds and calculated number of seeds to be 1220. Out of that, we found that round yellow was 701, smooth green 204, wrinkled yellow 243, wrinkled green 72. So the expected value is out of 1220 seats, 9 by 16 will be 7 of that will be 686.25 for the round yellow. Similarly, for smooth green, it will be 1220 into 3 by 16, that is 228.75. Similarly, for wrinkled yellow, same ratio 228.75, and for wrinkle green it will be 1220 into 1 by 16, that is 76.25. These are the expected values. And if we see in the fourth column itself, you can see fourth row itself, you can see the observed minus expected whole square value is 217.56 for round yellow, for smooth green that is 612.56, for wrinkle yellow that is 203.06, and for wrinkle green is 18.06. Now if we in the last column you will see that is according to the calculation, observed minus expected whole square divided by expected value for round yellow is 0.317, for smooth green that is 2.678, for wrinkle yellow that is 0.888, and for wrinkle green it is 0.236. And if you do the sum of all these four values, you will get a value of 4.12. Now the question comes of critical values. These are the calculated, the previous table we have calculated the values of chi-square. Now what are the critical values? So the critical values are already provided in the chi-square table itself. So you can see on the left side we have degree of freedom, and these are the probability level, and going by the statistical standard we will consider 95%, that is 0.05 probability level. Now on to the next slide, next step, that is the calculation of significance. So to begin with, we assume that the null hypothesis is true, that is H0 is true, and there is no significant variation between the observed and expected value. So this is our null hypothesis. Alternate hypothesis is the other way around, that is the observed value and expected values are significantly different. Now degree of freedom is total observations we have 4. The 4 minus 1 is 3. Now chi-square value for 3 degree of freedom in calculated value we have got previously is 4.12. If you see this slide, the last value is 4.12, right? Now chi-square for 3 degree of freedom at 95% confidence level, if you see it is 7.815. So the chi-square critical value is 7.815. Since chi-square calculated is very much less than chi-square critical, therefore we assume that null hypothesis is true, null hypothesis is accepted, and hence Mendel's law of segregation holds true for this case, this set of case. So it can be applied for different scenario to see whether the observed value differs very significantly as compared to expected value. So these are the applications of chi-square test. I hope all of you understand this.